Here's just a quick introduction to complex numbers. Complex numbers combine real numbers with imaginary numbers, like made-up numbers. There is a thought process that what happens when we take the square root of a negative number. When you guys type that in your calculators, it says domain error, because the domain of the radical function, the square root function, is numbers that are greater than or equal to 0. So anything that is to the right of 0 on the number line, and including 0, we can take the square root. We can type that in our calculators, we'll get a decimal approximation. We learned how to simplify radicals in a previous video. So what we're going to do today is imagine what would happen if we tried to take the square root of a negative number. Since our calculators can't do it, we have to use our imagination. So there are these imaginary numbers, and this will just kind of lay the groundwork for what you might get to do with complex numbers in this section, in future sections, in future jobs. I don't know what you guys got going on. But what we're going to do is see a couple examples defining and describing what happens when we take the square root with negative numbers. The first properties that you need to understand is, what if there were a number I, such that when you squared it, you got -1? Or another way to put that, what if there was a number I such that it equaled the square root of -1? In algebraic terms, the square root of a negative number a is equal to I times the square root of a. So here are a couple examples that we will try to investigate. First of all, we will do some simple items. The square root of -16, the square root of -100. And then we will investigate perhaps some more involved exercises. Let's try the square root of -32 and maybe the square root of -8. All right, so we are taking square roots of negative numbers, something your calculator can't handle, but you will be able to. So let's check this out. When we take the square root of -16, by this property here, we understand that this is the square root of -1 times the square root of +16. We'll separate this out as I times the square root of 16. Now the square root of 16, we know that is 4, so we have I times 4, which we are going to write as 4I. The square root of -16 is equal to 4I. The square root of -16 is 4I. With the square root of -100, most of us in the room can internalize this idea and take that to the next step to say, well, this is going to be the square root of 100 times I. And you'd be absolutely correct. The step-by-step on that would be the square root of -100 is I times the square root of 100, which is I times 10, which is 10I. All right? So there's a long way that we can write that out, or if we're pretty savvy with our perfect squares and understand this concept that the square root of a negative number is the imaginary component, or the imaginary root of that number. The square root of -32. Now here's where we have to be a little bit patient and take things easy. We're going to rewrite the square root of -32 as I radical 32. The square root of 32, that's not a perfect square, so it's not going to end up as a rational number. It's going to be an irrational number. So check this out. The square root of -32 is equal to I times the square root of 16 times the square root of 2. 16 times 2 is 32, so the square root of 16 times the square root of 2 is the square root of 32. This means that the square root of -32 is I times 4 times the square root of 2. How we will write this is 4I radical 2. That is our square root of -32. Let's look at the square root of -8. Maybe you can pause the video and try to do that one on your own. And maybe if you don't, then I'll get going on it right now. All right, I times the square root of 8. This is going to be I times the square root of 4 times the square root of 2. This is I times 2 times the square root of 2, which means that the square root of -8 is 2I radical 2. I hope that this helps you understand complex numbers. how to take roots of negative numbers and just imagine what it could be.